Brian Kernighan once wrote, "Everyone knows that debugging is twice as hard as writing a program in the first place. So, if you're as clever as you can be when you write it, how will you ever debug it?" Now, it's true that debugging is hard, but Xcode is here to help. And in this video, I want to walk you through some debugging techniques that can help make your life easier. I think debugging is best understood when broken down into 5 steps. I call them the 5 Ds of debugging. First, you discover you have a bug. You say, "It crashed." Then you determine what triggers it. It happens when I click this. Then you dissect that part of your code. It crashes somewhere in this loop. Then you devise a solution. I need to add a guard block. Then demonstrate it's fixed. I wrote a test. Xcode can help you with the second, third, and fifth of those. But in this video, we'll be focusing on just the second and third. Let's take a look at a dummy project. This class, ViewController, has 3 properties: test1, test2, test3, a UI table view, and 2 UI views. The first of these 3 gets created in viewDidLoad, down here. And there are a variety of methods being run: do foo, do bar, do baz, do wom, do bat. Each one is called in order and has a comment saying lots of code here. Sadly, the app crashes when it runs. Let's find out why. Press Command R now to build and run the code in the simulator. Boom. In do bat. Fatal error, found nil while unwrapping an optional value. Okay. Now, you can see someone has attempted to figure out their code flow using the very first approach you learn in debugging school, or at least would learn if debugging school were a thing. They scattered print calls everywhere. You can see print in do wom, print in do baz, print in do bar, print in do foo. So they can try to isolate where things are. Now, people who say they've never done this are lying, because it really is the first thing you reach for when you're learning debugging. And you can see down here all these print calls are coming out. And you can see there is no in do bat here. It only ends with after in do wom. So something's going on around about here between do wom and do bat, causing the problem. Okay. Now, if you are currently using this scattershot approach, let me introduce you to something much better, called watch variables. They take less work, take no cleanup, and reach places you might not even have thought of. So, to demonstrate this, I'll stop that and place a breakpoint up here where test1 is being created. Then press Command R to build and run again. Now, Xcode will pause automatically when test1 is hit there. It's not created yet, it's still nil, as you can see down here in the variables view. And what we're going to do is look inside self, here, self, for test1. Then right click on it and select watch test1. And that creates a watch point. It appears with your breakpoints in here. There we go, watch points 1, test1. And what's happening now is Xcode is watching that variable for us. So we're going to press Control Command Y to carry on playing through our app. And it pauses here in some random assembly code, but look at this output here. Watch point 1 hit, old value none, new value some, which means the value is being changed at this point. The value of test1 is going from none to something. Something's happening here. In fact, whenever view1 is changed now, Xcode will stop and tell us what's changed. All you need to do is switch to the debug navigator, then go back to the most recent code you ran. So you can see it's here. It's being changed right here. So we can see view1 is being set here, which is fine. Obviously it's being set there. So let's continue execution again to see what's being changed. So we'll press Control Command Y to play on. And it's hit again. Old value some, new value none. The last black thing here is do totally innocent thing, test1 is nil. So we can see test1's being destroyed here. It's common to have one method call another, which calls another, which calls another, and so on. So trying to scatter print statements around can be difficult. Here, the watch point's pointing us straight to totally innocent thing. We can just step back and say, well, it's being called in do1, which is being called from view.load. So you can walk through exactly how it's being destroyed and clear up that problem. So let's go to do1 and take out the do totally innocent thing call. That's the one that's causing this program to crash. And we're going to go ahead and press Command R again to run the code and see what happens. Okay, so it's hitting that breakpoint. Brilliant. Let's take that out now and press continue. Okay. So it's crashed again. In a different place this time, in a different way, but it's still crashing. So, this time it's a different crash, but it's much harder to read. Xcode prints all this junk in the console, and so it's really hard to find out what went wrong. You've got to really scroll through to look around. And worse, we were just thrown back to class app delegate, where nowhere near where the error actually happened. As you scroll way up in here, you will eventually find out what Xcode's tried to tell you. Way. There we go, okay. Unable to dequeue a cell with identifier cell, must register a nib or a class. Fine. Okay, so there's a problem with our dequeuing of cells for the table view, which is causing execution to go wrong. And that's nothing to do with app delegate, right? So, this is extremely tiresome to do every time, scrolling around trying to find the problem. So a better idea is to set what's called an exception breakpoint, which causes Xcode to pause execution whenever a problem happens. Let's try it now. Go to the breakpoint navigator. Then click this small plus button in the bottom left corner and choose exception breakpoint. Boom. Now it'll pause on all exceptions by default, but it's really best to choose Objective-C, which is what, of course, UIKit and AppKit and WatchKit and so forth, they're all written in Objective-C, so they'll hit those exceptions. And now we can run the code again. So press Command R to build and run. And hopefully this time it'll pause at a more useful place. Boom. It's now pausing here, telling us this line is the one that's actually causing the error. Which is great, but the console log says there was an assertion failure, but doesn't actually say what the failure was. Yay, right? So the app hasn't crashed yet, but an exception has been thrown, and it's been caught by our exception breakpoint. If we continue execution, then the app will crash as normal. So let's give that a try. So we can see an assertion is failing, but we're not sure what's actually causing the problem. So let's try continuing. We'll press Control Command Y to continue, and now it crashes again, just like before. The result is we're back where we were before. So we're back at app delegate, which is useless, and of course all this junk here gets printed out and so forth. And it's pointing us towards a line that's wrong, but it hasn't told us what was a problem until we go for a full crash. There is a solution to this, so let's try it again. When we run the app from scratch, it will pause at the line that's causing a problem. But this time we're not going to press Control Command Y to continue execution. So I'll press Command R to run the app. It'll install and run, and exception hit there. But we're not going to press Control Command Y. Instead, we're going to look in the debug navigator for this grayed out line here, Obj-C exception throw. It's grayed out because this is Apple's code running, not our code. But that's the line where the exception's actually being thrown. Now we can click down here in the console window where it says LLDB and type PO $arg1 and press enter. And you'll see this message here. It prints out the exact information we care about. So PO tells LLDB to print the Objective-C description of an object, and immediately we see the precise problem that was hit. We're trying to dequeue a cell that doesn't exist. Now, this workflow is so common and so useful, there are two further things I suggest you do. First, you should edit the exception breakpoint, like this. Go up to the breakpoint navigator and right-click on it, on the breakpoint, and choose Edit Breakpoint. And you'll see a button saying Add Action. Click on that thing now, and enter the debugger command directly in there. PO $arg1, like that. And that will run automatically as a debugger command for you. So it means execution will pause before the crash happens, but you'll see what caused it without having to go and use the debug navigator. Let's try it now. Press Command R again, build and run, install in simulator, and hopefully, boom. It hits the line, pauses there, and prints just the text we need, this bit here, to see exactly what the problem is. So that's great by itself, but a second tip, a really useful tip, is to right-click on the exception breakpoint and choose Move Breakpoint to User. And that makes that single breakpoint configuration, exception breakpoint with PO arg1 attached, shared across all your Xcode projects. So when you make a project next time, it will already be configured for this helpful tip. By the way, if you do edit breakpoints frequently, you might like to know you can bring up the edit breakpoint balloon by holding Alt and Command, then clicking the breakpoint. Now, there are two more things I want to demonstrate. First, let's run the app again so it hits our exception breakpoint. Okay, it's building and running again, back to here. And we'll break at the point it's going to crash. And we're going to find out what's going on. So we're going to say PO self, like this. And that'll ask LLDB to print out information about self, which in this case is view controller. And you'll see the output isn't very helpful. But we can fix that by overriding the debug description property. This needs to return a string, but it can be whatever string you want. In our case, the debugging person here who's working through this code is probably going to want to know the values of view 1 and view 2 and view 3. So we're going to make a debug description property that prints out those 3 values rather than this kind of junk here. And in fact, here's what I made earlier. Down here. I'll uncomment the code. So you can see you write override var debug description, returns a string, and return any string you want. So I'm putting back the value of test1, and then we'll do test2, and then we'll do test3, like that. Boom. We can go ahead and run that. And now when we hit a breakpoint anywhere in the app, we can do PO self, like this. We'll do PO self, and we get the values right back there. So you can see 1 is optional, the optional UI table view, 2 is nil, and 3 is nil. So it's our own custom message being printed out, which is much more useful. The last thing I want to mention just briefly is the ability to move the instruction pointer. Now, I've mentioned this before elsewhere, but so many people forget about it, which is a real shame. To try this out, we're going to place a breakpoint in our code. Let's do it on do bat, and then run the code. And of course, when it runs, Xcode will pause at do bat. But this green arrow here, that's the instruction pointer, this mint green bar. That's the line of code that's about to be executed, or at least would be executed if we let Xcode continue. Instead, you can just grab this thing on the left and drag it wherever you want it. So put it back in do foo. Now you can see the first time you do this, Xcode will warn you that it might have unintended consequences. As you might imagine, moving the pointer around like this will cause some part of your code to run again, or not at all perhaps. But for simple moves, it's usually safe. So I'll press move, and then continue. And you see it prints out again, do foo, do bar, do bars, do one. We just do it again, and move, and print again. So it's causing that code to run again and again and again, which is great for debugging problems.